Okay, I think only Srivatsan is there. Yeah. So all the exams are over? The revision
Yes,
exam?
Yes, sir.
Oh, good.
Sir, but they're actually killing us with practical work, sir.
Yeah, you should, right? It's been, I don't know, like you wouldn't have done anything for the past 1 year. It's good that you learned something.
No, sir, they
But
want us to
practicals, if they talk about record works and assign that works, then it sucks. Yeah, that I understand.
Yes, sir. I mean, record work only. Practical is fine, no, sir. You go and do and come.
Mm.
Plus, they're conducting our ASL, sir, for English, for
ASL means?
boards, speaking and listening.
Oh,
So
okay. Uh-huh.
today they did the speaking part, so I had to go to school.
Okay, okay, okay. Understood. This one was not there. They're not there when I was studying English, ASL and all.
So I
New
wouldn't care,
stuff.
but it's part of 10 marks for our board, sir.
Mm-hmm. Understood. So it's like something like practicals for English.
Yeah,
So
almost.
you'll write the exams for 90 marks in the boards, is it? For English?
80 marks, sir.
Right?
Another 10 marks for listening, sir.
Oh, okay. Understood. Still only you. So Srivatsan, were you a part of this CBSE 12th also when like the normal batch which is there?
Not
And
chemistry,
student?
sir. Math and physics, yes.
Oh, math and physics. Okay, so almost all of you are from already existing batch or anyone completely new? I think Varun is completely new, I guess.
No, sir. Varun was part of math and physics, just like me, sir.
Oh, okay, okay.
But Varun joined the thing late, sir. The
Mm-hmm.
JE camp late.
Understood, understood. When I took chemistry, I think Sri Harini, I saw Aditi, I saw chemistry they were attending because I took the physical chapters. Yeah, that ma'am already was taking organic and inorganic. So physical alone I took this year. So about next year, upcoming 12th, I'll be taking all the things. But 11th, I took everything. But yeah, minimum number of students were there. Only like the strength was less in chemistry. For math and physics, it was almost 25, 30. For chemistry, I was having only, I don't know, some 13. That strength was there.
Sir, do you take for 11th?
Yeah, I am taking for 11th.
Did you take for 2019 to 2020, sir?
No. This is the first time. This is the first year. If I complete this batch, this particular batch, 11th current batch, that's my first batch in F7.
Oh, so you joined in 2020, sir?
Yeah, 2020 March, like April, like that. Yes.
Oh, okay. So I was initially in Fiji, sir, with Varun only, sir. Varun was like
Okay.
my next room batch. They
Mm-hmm.
have some weird names for batches and all, CV012
Yeah.
something.
I don't tell me. I studied Fiji. Like I was in, what is it? Maharishi Vidya Mandir, Kilpak.
Sir, you were in integrated, huh?
No. Only weekend.
Oh, thank God. Okay.
Yeah. But again, like nothing happened. The faculties were good and all. Like I cannot really question the quality of the things which they gave. I was not that committed. Like I'll attend only chemistry classes. Maths to some extent I'll attend. Physics I'll bunk the classes. Like Skywalk is nearby, the next stop from Maharishi. So I'll just bunk and go there, sit. Like that's most 90% of the classes of I have bunked for physics. Like, and that eventually reflected in my marks in JEE mains.
Yes, sir. So that's what, sir. When I joined, I had that intention to go via the IIT route, sir, like the
Mm-hmm.
mains advanced route.
Mm-hmm.
So I joined IIT Fiji in 10th, sir.
Yeah.
So back then, what they were doing was they were training us for the NTSE exam, sir.
NTSC, yeah, Olympiad
Because what they do
NTSC.
is NTSE, then 11th KVPI, then 12th
Mm,
JE, then
mm,
focus.
mm, mm, mm.
So what they did was, they taught us the entire of 10th portions in a summer camp. May 9 to 4:30 we had a camp,
Mhm.
and I was all new to this, so okay, I thought there'll be something new, and I joined. It helped me a lot during my board, sir.
It's
So
okay.
so then what up? So my board marks, I actually did very well in math, science, and SST, sir.
Okay.
So I took Sanskrit. So this for the Sanskrit exam, the day before Sanskrit exam, I was very cocky and I went to play football, sir. I broke my
Okay.
leg that day.
Oh, very nice.
So then
Okay.
they gave me some injection and then they made me write the exam. The
Mhm.
the people there, I went to BVM, sir. So the pune and all carried me there to
Uh-huh.
the first floor.
Understood. Understood.
I was a
Understood.
little heavy back then.
Okay.
So that and all happened. But then in
Mhm.
11th, sir, I felt completely disconnected. They were overloading us in Fiji.
That happens. Like, see, there's the coping up with the syllabus which they teach, the pace in which they teach. Like again, it depends on the faculty. Like when I joined, the quality of faculties was really good, really good. But recent times, the intake, the faculty intake, since they want so many number of faculties, they just got anybody and everybody. It's like that. Maybe they will be good at problem solving. They'll be very good. They'll be from IITs. There's no there's not. It's not like that. But the teaching skills, right? So which pace students will understand or not. Okay, this is a better way of teaching a particular problem. That and all they'll not think. Whatever they feel is easy for them, or whatever they feel will be a shortcut for that particular problem. That's what they'll teach, and that happened in my batch also. But coping up in the sense, like if you're part of the integrated course, like say you're going to be with them for the next 2 years, that might actually bring in some logic in the sense that you will be in that particular
You get
state
used to
only.
it.
Used to it. Their routine, they'll make you come into their routine, and eventually you will do stuff because you'll see everyone doing it. If you are alone and not going to do it, obviously, if you are a good enough student, you will feel bad, and that's the routine they'll try to bring in. Integrated course actually makes sense, but Saturdays and Sundays course, yeah, you really have to. That's actually the Fiji. What they can do is only 10%. They'll just teach it and finish it, but other 90% is really in our hands. Like that's how it is. I know very few people who have cleared or say got into NITs or some decent college after the weekend program. Integrated course, yes, I know no so many people, cleared. They were in NITs. NIT Trichy, I know 4-5 guys. IIT Chennai, I know 3-4 guys. So a lot of other IITs. But yeah, weekend courses I've never seen actually. Like there is something. It's actually an eyewash only, the weekend courses, and that for that paying lakhs of money. Like you, like basically you must know what you're getting into. If you at least know, then you can actually eventually prepare. But out of, you just go there and then these something, everything is entirely new. Then as you said, yeah, you will feel you are not connected at all. You'll feel so much disconnected. That's what will happen. And that too, from in our education system, going from 10th to 11th is a huge jump in terms of number of chapters or the level of concepts. It's a very huge jump from 10th to 11th. Coping with that itself is very difficult, and in spite of that, going for JEEs and mains and advanced is actually a task. It is.
Yes, sir.
Anybody joined? Okay, Varun is there. Why today is was there any problem? Like only two of you are there, other than the English thing which you said.
No, sir. For us, we came back home pretty early, sir.
Okay. Fine. Time is almost 6:10, 6:11, and there's only two of you. Okay, fine. Cool, we'll start. We were doing problems on electrochemistry, so we'll continue. Actually, if it was a normal day, if it was normal times, I would have actually cancelled the class. But yeah, like I see that this is what is happening for the past few classes. The strength is pretty less, right? So we'll continue. Okay. Fine. See, they have given this reaction. Cu, the E naught value is 0.34 volts. And one more data they have given is the KSP value of copper hydroxide is 10 to the power minus 19. And they're asking, what is the E naught of Cu2 plus bar Cu when the pH is 12? When the pH, or say when this is coupled with a pH solution which is having a pH of 12, a solution which is having a pH of 12. Okay, try to do this or try to think about it. How will you approach this problem? Right, so they have given the E naught value of this copper, and they have given copper is copper hydroxide's what is that solubility product, right? And they're asking you, when I have this coupled, when I have Cu2 plus bar Cu coupled with the solution which is having pH of 12, what will be the E naught value of this particular cell is what they're asking.
Sir, so is it like 4s cube equal to 10 power minus 9?
Yeah, so what you have to do is they have given you KSP. What is KSP? KSP, you know how to calculate, right? So it's basically, for this, it will be 4s cube. Yeah, it will be 4s cube, right? So basically that what we need is concentration. For the Nernst equation, what we need is the concentration, right? So what is S there in that KSP? What is that S?
Sir,
Solubility.
like
How do
S
you
is the concentration only, sir, in that.
Exactly.
that.
S is the concentration. So if you can find S, you know what is the concentration of Cu2 plus, right? And from the pH, you know what will be the concentration of the H plus, right? So now you can use the Nernst equation, go for log of products like reactants or whatever it is, substitute the values, you'll be able to get the answer. Go for it. Actually, I should not call it as E naught. It is E cell. right? So what you have to understand is, guys, it is, see, it's like I have this particular cell, right? So when all the concentrations are 1m, the value is this much. We know what is standard reduction potential, isn't it? Right. So that we know, right? Now, when I give pH, I have a solution of copper. When I have a solution of copper hydroxide in a pH of 12, uh, that means something. It is not like the cell is coupled, right? Say if I have to explain you, see, I know copper hydroxide will give me copper 2 plus 2OH minus, so it will be S and 2S. So it will, the KSP value would be 4S cube, right? But you should not be doing it this way. Now, why I'll tell you. Now you see the OH minus concentration is it's not only coming from copper hydroxide. They see this is the pH of solution is having 12, right? So obviously I know the pOH value will be 2.
So 10 power minus 2 will be the OH minus.
Correct. So the OH minus concentration will actually be 10 to the power minus 2. That will be the concentration of OH minus. And compared to this, you know what is the KSP value? 10 to the power minus 19. See, look at this. Right? Compared to this value is very, 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 very high. Say this is like a problem which we did in solubility product. AgCl, KSP in the presence of NaCl. So at that time, I don't know. You hope you remember what we did. We took the concentration of Ag. Correct. We took the concentration of Ag plus, yes, right. But when I went for the concentration of Cl minus, I took whatever the concentration of Cl minus coming from Na plus only. I mean NaCl only, because NaCl is a strong electrolyte. The amount of Cl minus it will give will be very, very high compared to AgCl, right? So that Cl minus concentration from AgCl is neglected, and whatever the concentration is coming, or concentration of Cl minus just coming from NaCl, that only was put here. The same thing we'll do here also. Compared to this OH minus concentration, from this solution, the OH minus concentration is pretty high. So I will be able to neglect this concentration. So instead of writing 2S here, I write 10 to the power minus 2. Are you able to understand what I'm saying? Right? The compared to this would have been 2S. But that value is going to be very, very less compared to 10 power minus 2. So I neglected. So it should have been 10 power minus 2 plus 2S, but this can be neglected because it's a very small value. Right? So now you can easily find what is the concentration of CO2 plus. Right? Then use the Nernst equation. That's it. A Nernst equation, what will you have? We'll have E is equal to E naught minus 0.059 divided by, I know the number of electrons is 2 log of, and now you see this is the only reaction happening. This is the only reaction. So it will be copper concentration divided by CO2 plus concentration. I know copper is a solid, so we'll take the active mass as 1. So it is just going to be concentration of CO2 plus only. And that's what is founded by this S value. This S what you have to substitute here in the place of CO2. Understood? Yes? No?
Wait, sir. So how do you find S? 4S cube is equal to 10 power minus 19. Should we put or?
No. This is S into 10 to the power minus 2 is KSP.
Is equal. Oh, okay.
Is equal to KSP.
10 power minus 19.
10 power minus 19. Exactly.
So 10 power minus 17 will be the.
Exactly. So the log of the concentration of CO2 plus is 10 to the power minus 17. That's what you have to substitute. Yes? Understood?
Yes.
Yes, sir.
Okay. So, like, see, if this is how advanced questions would be. Like, if you go for a JEE advanced, this is how it will be actually. They will just combine 2-3 concepts, one from thermodynamics, one from equilibrium, one from electrochemistry. Just combine everything and give you a question. That's it. That is what is JEE advanced. At least in chemistry, that's what happens. Right? Okay. So I think if you calculate, you will get the E in E cell as minus 0.1 volts. So this value, you'll get it as 0.10 volts. Okay. Right. Okay, we'll go to the next question. Right. So there is something called as temperature coefficient of EMF. Okay. So there's something called as temperature coefficient of EMF, right? So that is actually going to come from combining these two equations. So I know delta G is equal to minus NF V naught, right? And I know delta G is equal to delta H minus T delta S. Okay, right. So I'm actually going to combine these two equations and I'm going to get something. So we'll see what I'm going to do. 1 second. This T delta S okay, maybe I'll do it in my way. So if I do this minus NF V naught is equal to del H minus T del S. If I just keep E naught alone here, I'll get minus delta H by NF plus T delta S divided by NF, right? We're talking about temperature coefficient. So temperature coefficient in the sense how the EMF varies with respect to temperature is what I need to know, right? So what I need to know is this term dE by dt. If I increase temperature or if I decrease temperature, what will happen to my E naught value is what we're trying to find out, right? So if I do it, right? So my dE by dt by d naught capital T temperature, right, will be equal to, now if I differentiate with respect to T, this term with respect to T, can I say this will go to 0? This is a constant, right, with respect to T, right? So this goes to 0. So now this whatever I have is my delta S divided by NF. It's like differentiation of A into X is A, right? So this is my delta S by NF is my this thing A, and T is there, so it will just go off. So this is what you need to know. Okay, so this is what is called as my temperature coefficient of EMF, right? So dE by dt is equal to delta S by NF. This you have to know, right? I have seen recently questions coming from these also. Okay, so this I wanted to tell. Okay, so please remember this temperature coefficient of EMF, right? This is not there in your NCRT. So they might give even problems based on this. They just ask you to find what is the temperature coefficient, right? They just give you what is the delta S value, right? And they say that they'll give you a reaction, say Fe2 plus 3 electrons gives Fe. So you know the number of electrons there would be 3. So you know the F value is 96,500. So you can just calculate. Okay, right. So next question is, they have given E naught of Fe2 plus bar Fe, is it? Yeah, is 0.439 volts, and they have given E naught Fe3 plus bar Fe is minus 0.036 volts. Okay, now they're asking what is the E naught for Fe3 plus bar Fe2. Okay, so they've given Fe2 plus bar Fes and Fe3 plus bar Fes E naught. They're asking you Fe3 plus bar Fe2 plus. What will be the reduction potential value? Right, this kind of problems you should have solved for your NCRT. How will you do it?
Sir, find which reduces better and subtract.
Okay, say let me give you let me ask you a question. Say I have A giving B, for this say it is E1 naught, B giving C, it is E2 naught. So if I have A giving C, what will be the E naught value? Can I say it as E1 plus E2?
Yes, sir.
That's what you should not. Right? It is not equal to E1 plus E2. Just if you add these two reactions, you will be getting this reaction. Right? But please understand your E naught is not an energy term.
Sir, we
Right?
have to add the Gibbs energies, no, sir, and then we can.
Sorry?
Because that Gibbs energy can be added, no, sir.
Correct.
That
Correct.
concept
That is how you have to do it. Right? So basically, whatever you cannot directly add the E naught values when you have two reactions, when you cannot subtract. Say, for example, if I multiply this by 2, you cannot write this as multiplied by 2. It doesn't work like that. The only thing which you can do is this. Say, if I have A giving B is E naught, if I write B giving A, for that I can write minus E naught. This you can do. Okay, when you reverse the reaction, you can reverse the sign of the reduction potential value, but no other thing, just like you do in energy terms, like you can multiply there. When you add the energy terms. No, that you cannot do directly in terms of E naught. You have to convert that E naught into delta G. Then you can do whatever you want. Okay, right? Fine. So can you go for this? First write these two reactions, right? This reaction also you write. You see where what is required. I require Fe3 plus in the reactant side. I require Fe2 plus in the product side. So accordingly, you change the signs, right? And obviously, you need to have one electron and stuff. So anyways, you try to do it, right? You convert the E naught values in terms of delta G, right? So now when you add or subtract, this will have a delta G value, right? That will again be equal to some N of E naught of this. You know the number of the number of electrons involved here. You know the F value. You have calculated the delta G value from these two. So E naught value can be calculated for this particular reaction. This is how you have to do these problems. Go for it. Tell me the answer. See, like do not calculate entirely. You just keep F as F only, right? Because here also F is going to come. Here also F is going to come. You can cancel it when you calculate the E naught value. Okay, so keep F as F only. Do that. Fe first reaction Fe2 plus 2 electrons gives Fe. For this I'll just keep it as E1 naught. I don't know, the value is 0.439. And then Fe3 plus 3 electrons gives Fe, say this is E2 naught. And I want the reaction to be Fe3 plus 1 electron gives Fe2 plus. For this is the required reaction. I don't know, whatever it is, this is E naught. Okay, right. So if I convert this into delta G, now can I say delta G1 will be minus N is 2, F is F. I can write it as E1 naught. This for this reaction, delta G1 is minus 2 into F into E1 naught. Okay, for this, it will be minus 3 into F into E2 naught. This is what is the delta G2 for this. Okay, right. So now what I need to understand is I want Fe3 plus to be in the reactant side. Okay, Fe3 plus in the reactant side. I want Fe2 plus in the product side. So obviously I have to reverse this reaction. Right. So if I reverse this reaction, it will become Fe becoming Fe2 plus 2 electrons. So you have to change the sign of delta G, or you can change the sign of E naught also. But whatever it is going to become plus 2 into F into E1 naught, because you have reversed it. No issues, right? Now then if you add these two reactions, so 2 electrons in the product side, 3 electrons in the reactant side, I'll have 1 electron in the reactant side. So no problem, right? So sometimes you have to multiply also, but in this case you don't have to multiply anything, right? Okay, so that is done. So now what I have to understand is this E1 naught or E naught, if I write the delta G here, delta G is equal to minus NF into E naught. Okay, and this delta G, I'll just rub this part. The delta G which you wrote here, can I say it will be delta G1? I will say this is delta G1 for the forward reaction. For the reverse reaction, it would have been minus delta G1 plus delta G2. Hope you understand why I put a negative sign, because I've reversed the reaction, first reaction, right? So how will I write it? So I can write this delta G is equal to minus N is number of electron is 1 F into E naught. I'll just keep it like that, right? Now is equal to minus delta G1 is plus 2 into F into E1 naught plus, and there is a minus 3 into F naught. So it will become minus 3F into E2 naught. No issues. So I can easily cancel the F's. Okay. So if you easily cancel the F's, it is going to be E naught is equal to minus E naught minus E1 naught. I'll just bring the minus sign this side. Am I doing something wrong? No. That's it, right? So it is going to be minus E1 naught minus 2 E1 naught minus, or this will become plus 3 into E2 naught. This would have been the answer to this question. You just have to plug in the values. E1 naught, you know what is the value, E2 naught, you know what is the value. You just have to plug in here. Just like how you did in thermochemistry, except that at the last step, you have to convert your delta G into in terms of E naught, because E naught is what is asked this question. Okay, pretty simple problem. Everybody understood? Yes? What we did here? You want me to explain again, or everybody understood?
Sir, can you tell how you reverse the reaction?
Oh, so this was, if I reverse the reaction, it will become Fe becoming Fe2 plus 2 electron. So now the E naught value, whatever the E naught value was, first one was given to be how much? It was minus 0.439. It will become 0 plus 0.439 volts. That's it. Then calculate the delta G. Is it okay?
Yes, sir. Yes, sir.
Right, you had this reaction, you reversed it, you change the sign of the E naught. E1 naught initially was minus 0.439. Now it became plus 0.439. Accordingly, delta G value will change. Minus, it will become positive, or plus will become minus, whatever it is. Then you add these two, this reverse reaction with this reaction you add, right? Then you can add the delta G values also. So the delta G of this reaction is equal to sum of the delta G's of these two reactions, right? So this delta G I can write it as minus NF naught. So this again can write it as in terms of NF naughts, right? So I can eventually calculate what is the required E naught from the given E naught values. Maybe we'll do one more problem. Maybe you'll understand.
Sir,
Yeah.
we don't have to balance the equations or something.
So the thing is here, you don't need to balance. What I need to get is this equation. For getting this equation, if you want to multiply anything, then you can multiply. But in this case, I don't have to multiply anything because when I just add, I'm going to get this equation, nothing else. Do you understand? So the thing is, this is what is the required equation. This is given in the question. This is what is wanted for me. And this is got from the given equations. There is no need to this thing here. What do you mean by balancing?
So like you added the two equations.
Correct.
Okay, sir.
I
Yeah.
added the two equations to get this equation. That's it. Okay. Okay, maybe if you do this problem, you should be able to get the answer pretty easily. So they have given E naught Cu2 plus bar Cu is 0.15 volts. E naught In3 plus bar In or In3 plus bar In plus is minus 0.42 volts, and E naught of In2 plus bar In plus is 0.40 minus 0.40 volts. Okay, they're given these three datas and they want for this reaction Cu2 plus In2 plus gives Cu plus, oh, so Cu plus. Okay, so Cu plus In3 plus. Okay, they want the log of basically this is a reversible reaction. They want log of Kc for this reaction. Okay, so that's the required equation. These three equations are given to you, and for this reaction I need to find what is the log of Kc because that is a reversible reaction. Okay, now before we move on to the problem, tell me what is the relationship connecting any thermodynamic quantity with the equilibrium constant?
Delta G is equal to 2.303 log Kc.
That's it. 2.303 log Kc. That's it. What is the exact equation?
Oh, RT into RT.
Yeah. So delta G is equal to minus 2.303 nRT log of Kc. This equation you have to remember. Not only here for equilibrium problems, for thermodynamic problems, lot of times this is used. Okay. So delta G is equal to minus 2.303 nRT log of Kc. So anyways, so what you have to first find is the delta G of this reaction. If I can find the delta G of this reaction, then I can use this to find the log of Kc. That is very simple. And you know how to find the delta G. Like you have to do something to these two equations, these three equations, so that you will be getting this equation. And you know the equivalent delta G's of all these three. So whatever you do, just add or subtract or multiply, whatever it is, do that to get the delta G of this and then get the log of Kc value. Go for it quickly. So write the reaction first, see what is required, where it's required, whether in the reactant side or product side, how much is required. So please don't just sit, take in notebooks and solve it. Okay, by this time you should have done something to these three equations so that you will be getting this equation. Is it done? Forget about the calculations, but something has to be done to these three equations so that you should have gotten by this time this equation, required equation. Is it done?
Yes, sir.
Okay, maybe that alone we'll check how we're going to do it. I'll just
Ah,
rub
yes.
this part. Okay, so first is E naught Cu2 plus bar Cu plus. So I have Cu2 plus accepting one electron to form Cu plus, and this is E1 naught. E1 naught is given as how much? 0.15 volts. I don't know the values also. Calculations, I'll tell you what is the answer. E1 naught. Okay, and then they have given me In3 plus bar In plus. In3 plus 2 electrons is going to form In plus. Say this is E2 naught. Okay, then I have In2 plus, forming In plus. So this E3 dot. Okay, right. So let me go to the required equation. I require Cu2 plus in the reactant side. Okay, Cu2 plus in the reactant side. I require Cu plus in the, okay, Cu plus eventually will come in the product side. I require In2 plus in the reactant side, right? So In2 plus is here, reactant side, right? Now what I want is In3 plus should be in the product side, and in this case you see In3 plus in the reactant side. So obviously this has to be reversed, is it not? Cu2 plus in the reactant side, okay. In2 plus in the reactant side, okay. Cu plus in the product side, okay. In3 plus should be in the product side, but here it's the reactant side, so we'll reverse. So this will become minus of E2 naught. That's what will happen if I reverse it. Okay, right. Fine. So this will become, if I convert it to delta G's, now this will become minus
Minus F
2F.
into.
There are one electron only. Yeah, sorry. Yeah, one electron minus F into E1 naught, right? And for this delta G, for the converted case, for the reverse reaction, it will become say because there's a negative sign, I'm putting a
2F
positive
into
sign.
E2,
See,
sir.
yeah, so here I have 2F into E2 naught. It should be minus F into E naught because I have put a negative sign. Now I'm changing it. Okay, and for this it will be only one electron, so it will be F delta G. Okay, I'll call it as delta G1 here, delta G2, and delta G3 is minus F into E3 naught. Done. Okay, so now you can see if you just this plus this 1 plus 3, and you have reversed this reaction. So just if you add all these three, the addition of these two and the reverse reaction of this, you will be ending up with this equation. You don't have to worry much. Okay, right? So now what happened for this delta G is what, for this let me keep it as delta G, right? Now delta G is basically going to be equal to my sum of all these three. So it will be minus F into E1 naught plus 2 into F into E2 naught minus F into E3 naught. Okay, so that's it. Now you have calculated everything. Now you can find for calculating, go for calculating the value of log of Kc. Okay, so this thing is not important. Calculation is not important. Yes, it is important for you to get the answer, but the more important thing is how do you modify these equations to get this equation along with the delta G values. That's what is more important. It's exactly same as thermochemistry, except that only one more step you have to include. That is converting E naught into delta G. That if you do, everything is same.
Sir, is the temperature of the reaction given?
Obviously they should give. They didn't give, so you can keep it as 25 degrees Celsius. They didn't give anything.
298 Kelvin, sir.
298 Kelvin. Yeah, temperature will be 298 Kelvin. Okay, so like this, thermodynamics and electrochemistry can be combined. Okay, now the last part of this electrochemistry is Faraday's laws. So we'll just do a couple of
Sir?
problems on that. Yeah.
What would be the number of electrons in the main equation?
That you have to calculate, right? So what you're seeing here is Cu2 plus becoming Cu plus. So for this it is 1 electron. Now In3 plus becoming In3 plus, again 1 electron only. So a number of electrons is 1. Are you understanding what I'm saying?
Yes, sir.
Right? Cu2 plus 2, Cu plus 1 electron, In3 plus 2, In3 plus, again 1 electron. Right? So but if it was 2 and 3, then the number of electrons will become 6, because you will match these two to get no electrons. At the time it would have become 6. Anyways, so in this case it is only 1. Right? Okay.
Sir,
So,
how do you quickly calculate, sir?
how do I quickly calculate? Like look at
Like
this.
during the
Say,
exam?
pretty
No, sir,
simple, right?
Like I'm getting 0.17 by 2.303 into R into 298, sir.
Okay. Oh,
So
you're
how
asking
do
how
I?
to quickly calculate. Okay.
Yes,
So
sir. Because
okay, and that yeah,
during the
like
exam
see,
I need to calculate.
approximately. I understand what you're asking. So approximately is what we have to do. So what you're telling, you can did you calculate the delta G value, or how much is it? Did you calculate?
So 0.17 F, sir.
Oh, this entire thing will become
Ah.
0.17 into F. F is 96,500. Right? So is equal to minus of 2 point. This is more, then this is negative or positive?
Positive, sir. Minus
Positive.
F and then minus 0.7. So.
Okay, fine. So it will be 2.303 into number of. What are they telling about number of moles here? We just take it as 1. That doesn't matter. So into 8.314 into 298 into log of Kc. Okay. So whenever these kind of things come, right? So I would go for a very rough calculation in the sense that this can be easily calculated. This you should calculate. There is no other go. What you can do is you can convert this into 300 instead of keeping it as 298, right? And you can just keep it this as 2 and this as 8, and then calculate. See what you're getting, right? And eventually, but this much approximations can be done only if the difference between the choices given to you are pretty large. One is some 10, another is some 100, like, or say at least some considerable difference should be there. right? Not like 31.2 and 31.4. If those are the options, you cannot do it,
Yes, sir.
right? But if the options are pretty far away, then you can actually go for a very good approximation. Say convert this to okay, keep 8 as 8.24 as 8 and convert that to 300, right? Then you can make it little simpler. Okay.
So if it differs by
Correct.
like 1/10, something like that,
Yeah.
then
Yeah, you can do it. You can do it, and mostly
okay.
it will work. Mostly you will work. It will work.
Okay, sir.
Like
Fine,
converting
sir.
like this,
Yes, sir.
right? Okay. So where is my Faraday's laws? No Faraday's laws. Ah, yeah, got it. Okay. So hope you know what are the two Faraday's laws, right? Faraday's first law and Faraday's second law, right? So Faraday's first law tells you that the amount of electricity you pass is directly proportional to the amount of substance getting deposited. Correct, right? And your second law talks about if I pass the same amount of electricity to three different solutions of three different electrolytes, same amount of electricity, right? So the ratio of these masses deposited is directly proportional to the equivalent masses. Like, guys, do you want me to take you want to take down the statement again, or you know the statements, two statements? Yes, no? Okay,
Sir, can
fine.
you
Take the,
tell?
yeah,
Yeah, tell,
take
sir.
down the statement. Take down the statement. Faraday's first law. The mass of substance deposited, the mass of substance deposited at any electrode is directly proportional to the quantity of electricity is directly proportional to the quantity of electricity passed through the electrolyte. Okay, passed through the electrolyte. So if you tell it overall again, the amount of substance deposited at any electrode is directly proportional to the quantity of electricity passed through the electrolyte. Okay, now it makes sense, right? Does it not? Say if I have something like copper 2 plus 2 electrons forming copper, remember, till now what we're doing it about your galvanic cells, right? Galvanic cells convert chemical energy into electrical energy. They produce electricity, galvanic cells. And now what you're seeing is electrolytic cells. Electrolytic cells is opposite. Electrolytic cell, you supply energy for the reaction to happen. Is it not? Right. So that energy you supply is going to be in terms of electrical energy. So you supply electrical energy for making a non-spontaneous reaction occur. That's what you're trying to do here. Okay. So what they're telling is the amount of electricity you apply, right, is going to be directly proportional. The amount of electricity you apply is directly proportional to the amount of substance getting deposited at any electrode, right? So hope you know how a galvanic or how an electrochemical cell works, right? So for example, if I have an NaCl solution with me, right, and I will have two electrodes, one connected to the positive charge, another connected to the negative charge, something. Okay, so you have Na plus ion and Cl minus ion, right? Now these charged ions are going to move towards their oppositely charged electrodes. For example, Na plus is positively charged, so it is going to move towards the electrode which is negatively charged. And obviously you see this is the negatively charged electrode, right? So negatively charged electrode will have a higher amount of excess number of electrons because it is connected to the negative terminal of the battery, right? So this Na plus will go towards the negatively charged electrode, and negatively charged electrode will always be a cathode, right? So the Na plus will move towards the cathode, right? So now the cathode has excess number of electrons. Now it is the sodium solid is gonna get deposited. Same goes with Cl minus also, right? Now Cl minus is negatively charged, it is going to move towards the positively charged electrode, and that case is my anode. Anode is what is connected to the positive terminal of the battery. Right, this is how you supply electricity. Okay, so now Cl minus is excess of electron and anode is positively charged. So the Cl minus is going to donate electron to the anode, or say the anode is going to abstract electron from the Cl minus, right? So you'll have two Cl minus forming Cl2 by loss of two electrons, right? So in the cathode, you will have sodium getting deposited, right? And in the anode, you will see chlorine gas getting evolved. So these are what are the substances we're talking about. So in each and every electrode, you will have some kind of substance getting liberated, right? Now, what is that amount of substance getting liberated is going to depend on how much electricity you are going to pass. Okay, that is what your first law says, right? So when I say amount of electricity, I am basically talking about the charges. How much charge, right? How much charge is getting donated? Right? In the sense, amount of electricity in the sense, amount of charge is what you have to understand. Right? Now we can easily calculate what is the charge, right? Charge, I know our current is rate of change of charge, that is Q by T. So I can write Q as I into T. Okay, so what we're trying to tell here is the mass is directly proportional to I into T. I into T will become charge. The mass is the mass getting deposited, right? So in your book, they have given this equation, M is equal to Z into I into T. To remove the proportionality sign, I put a constant. And this Z is what is called as your electrochemical equivalent. Right? This Z is what is called as your electrochemical equivalent. Right? But what you have to understand is, people, I really don't need this term for me. I really don't need this equation. Right? If I'm a little good at stoichiometry, right, I will be actually able to do these kind of problems. Okay, for example, right, no, I hope you understood what is the theory behind it, right? Okay, so what I'm trying to tell you is we don't need this equation, right? Now let me take an example. Okay, say I have Al3 plus accepting 3 electrons to form Al. Aluminum is getting deposited. Okay, right. Now I say, what do I say? Say 2 ampere current, right, was passed through the solution, aluminum, whatever solution we have, aluminum salt solution, right? So 2 amperes current was passed for 2 hours. Okay, 2 amperes current was passed for 2 hours, and I ask you what is the mass of aluminum getting deposited? Very simple question, right? So 2 ampere current for 2 hours, right? And I'm asking you, what is the mass of aluminum getting deposited? Okay, right. Fine. So now what I'm going to do is I'm going to imply stoichiometry here, right? I'm going to do the stoichiometry with respect to the number of moles of electron, and obviously you see 3 moles of electron gives 1 mole of aluminium. That's what I understand from the stoichiometric equation, is it not? 3 moles of electron gives 1 mole of aluminium, right? Now how will I talk about number of moles of electron? Now you see, number of moles can be spoken in terms of mass, volume, or number of particles, right? But I can little extend it. I can little extend this number of moles definition in terms of charge. Now, very simple, right? So I know what we say. For example, the say number of moles of sodium. If I want to speak, what do you say? Given mass divided by molecular mass of sodium or atomic mass of sodium. Now, what is atomic mass of sodium? Atomic mass of sodium is going to be actually what is the mass of 1 mole of sodium. Let me tell. See, number of moles of sodium is given mass of sodium divided by the atomic mass of sodium, right? And what is atomic mass? Atomic mass is basically mass of 1 mole of sodium. That is how we define molecular mass or atomic mass. It is the mass for 1 mole of the particular substance, right? Now same analogy can be brought here also. If I want to find the number of moles of electrons in terms of charges, it can be written like this: given charge, given amount of charge divided by charge of 1 mole of electrons. Is it not? Just like how you did here, given mass divided by mass of 1 mole of sodium. Same way you can write number of moles of electron is equal to given charge divided by charge of 1 mole of electron. Can you tell me what this term is? What is this charge of 1 mole of electron? We didn't discuss, but you should have done it in your school, isn't it? What is this charge of 1 mole of electron? Can you calculate? What is the charge of 1 mole of electron? Can you calculate and tell me? You know, 1 electron's charge is how much?
1.6 into 10 power minus 19.
1.6 into minus 19 coulombs. In 1 mole of electron, how many electrons are there?
6.022 into 10 power.
Correct. So if I multiply these two, right? So this charge will come back to this question. Okay. So if I have to find this value, it is basically 6.023 into 10 to the power 23. This is the number of electrons in 1 mole of electron into charge of 1 electron. Charge of 1 electron is 1.6 into 10 to the power minus 19. Okay. Now this value, if you calculate, approximately you will get 96,500 coulomb per mole. What is this? 9,500?
Faraday's constant.
Exactly. Faraday's constant. This is the definition. When I say 1F, that means charge of 1 mole of electron. 2F means charge of 2 moles of electron. That F is a constant. Because this is how it's calculated. Okay, right? So now I can easily take the formula easily as this: given amount of charge, I write GQ. GQ is given amount of charge divided by F. That is how you find the number of moles of electron. You can see here it is coulomb. This is coulomb per mole. So coulomb gets cancelled. Per mole going to this thing will become mole. So now you'll get just mole as a unit. Okay. So you can see the number of moles of electron can be calculated as given amount of charge divided by F. Okay. So now going back to that question, right? Just take this down. Now we take down the formula alone. Number of moles of electron is equal to given charge divided by F. Right. Now if you know this, now this question is very easy. Al3 plus accepting 3 electron to form Al. Now I told you that I had 2 ampere current for 2 hours. Right. Now you can find the amount of charge given this GQ. You can easily find from these two values. Right. So the given amount of charge is I into T is what I have to know. Okay, charge is equal to current into time. Right. So 2 into 3,600. Please understand it should be ampere per second. I'm sorry, ampere second. As that is coulomb. Okay. So it should be in terms of seconds. That's why I'm multiplying by 2,600. Anyways, now you have calculated what is the amount of given amount of charge is how much you calculated. Now you calculate the number of moles of electron. That is 2 into 3,600 divided by 96,500. Right. Now this is the number of moles of electron. Okay. Now you can easily calculate what is the number of moles of aluminium. Right, because 3 moles of electron gives 1 mole of aluminium. So can I say this many moles of electron will give number of moles of aluminium to be 1 by 3 into this value? Is it not? 3 moles gives 1 mole. So obviously this many moles will give 1 by 3rd of that. That's it. Guys, did you understand what I'm trying to say? You really don't need to use this formula. This calculation of Z is little complex. Okay. Right? So you go for this. You already know stoichiometry. You already know what is the current charge relationship. Right? Now you know how to calculate the number of moles of electron and do the stoichiometry to find what is required. Everybody understood? How am I telling it's 1 by 3rd of this? Everybody understood how I got the answer? The number of moles of aluminium? Yes?
Yes, sir.
Okay, right. Cool. Now we will do some problems on this. Okay, take down a question. I'm dictating a question. Please take down. So only two formulas you have to remember here. One is this: given number of moles of electron is given charge by F, and the second thing is charge is equal to current into time. That's it. And then the stoichiometry. That's it. Okay. So okay, fine. Take down the question. During electrolysis of AgNO3, during electrolysis of AgNO3, a current of 5 amperes, a current of 5 amperes was passed for 2 hours. A current of 5 amperes was passed for 2 hours. Okay, now they're asking, find the weight of silver deposited. Find the weight of silver deposited given that the sample was 95% pure. Given that the sample was 95% pure, P-U-R-E. Okay, so I'll repeat the question, right? So during electrolysis of AgNO3, right, 5 ampere current was passed for 2 hours, right? So they're asking you what is the mass of silver deposited, given that the sample given to you is 95% pure. Okay.
Sir, atomic mass of silver is?
Ag 108. Atomic mass of Ag is 108. Yeah, 108. Right. See, the only extra thing which I've given you is about the purity. Right. So the solution which you have, AgNO3 solution you have is only 95% pure. Right. So whatever you are doing till now, you calculated for aluminium, that is considering that it is 100% pure. Right. So whatever the answer you get at the time, at that last, take 0.95 into that value is what is going to be the answer. Okay, because it is only 95% pure. Other than that, nothing else is changed in this question. So this is a reaction you have to look for. Ag plus electron gives Ag. Okay, now they are given this to be 5 ampere current for 2 hours. This is the amount of charge. Anyways, you do it. Or in your school, if you have become comfortable with this kind of solving problem, then you can go for it. There is no restriction here. I feel this is more easier rather than using the formula. Okay, so this is the amount of charge Q, right? So if I calculate number of moles of electron, which is Q by F, which is 5 into 2 into 3600 divided by 96,500. This is the number of moles of electron. Now you see 1 mole of electron gives 1 mole of Ag, right? So obviously number of moles of electron and number of moles of Ag will be same because 1 mole gives 1 mole. So 5 into 2 into 3600 divided by 96,500, right? Now they were asking what is the mass, right? So I know number of moles into the molecular mass or atomic mass is going to give you the mass value, right? So mass of Ag would be 5 into 2 into 3600 into 108 divided by 96,500. That would have been the mass for 100%, right? So if you calculate what is the mass of 95% Ag, so this entire value 0.95 into 5 into 2 into 3600 into 108 divided by 96,500 would have been the answer to this question. Okay, guys, everybody understood what I did here? In this case, the stoichiometry is pretty easy. 1 mole of electron gives 1 mole of Ag. So whatever is the number of moles of electron I calculate by this formula, Q by F, will be the number of moles of Ag also. Now I'm finding mass of Ag. Mass of Ag will be this into the atomic mass. Number of moles into the atomic mass, which is 108. And they're asking for 95% purity. So this is for 100%. So take 0.95 into this value. You are going to get the answer to this question. Is it okay, guys? Fine. Cool. Did you understand or you want to explain again? Is it okay?
Understood, sir.
Sorry?
Understood, sir.
Okay, cool. Right. Fine. One more question. I think we'll just do 2 more questions and we'll wind up this and 1 more question. And guys, do not worry about your portions completion. Okay. So anyways, we'll be continuing, right? So you should be doing something. Just you don't have to wait for me to complete the questions. You can start writing. I don't know. I have told you long back. You should have started writing your mock tests. Okay, you continue doing the mock test 1 day per 2 tests, or at least 1 day 1 test and analysis, right? So that you keep on doing, eventually will complete it. So we have, after this, we have to go for solutions, solid state, surface chemistry, and metallurgy. Surface chemistry, metallurgy 1 day. Solution, solid state again. In 4 or 5 classes we'll be completing. Don't worry. You don't have to worry about it. Okay, right? Do not worry. Like now, why am I not worried? Is because you will be in the peak. I mean, at least remembering case, they will be in the peak of 12th your school, whatever they have taught you. So only little I have to teach you more. Metallurgy chapter I will teach you. Don't worry entirely. But other than, you don't have to worry. Rest all concepts are in your hands. I'll tell you just, I'll guide you through how to do the problems. Okay, fine. Next question. Right. W grams of Ag. W is a letter. W grams of Ag is deposited. W grams of Ag is deposited by passage of 1 ampere current for 1 hour. By passage of 1 ampere current for 1 hour. Okay, right? Now they're asking, what is the time required? What is the time required to deposit? What is the time required to deposit W grams of magnesium, Mg? W grams of magnesium by a current of 1 hour. By a current of 1 hour. Okay, again, repeat the question. W grams of Ag is deposited by a passage of current of 1 ampere for 1 hour, right? Now the question is, find the time required for depositing W grams of Mg, same W and W, same 1 hour current, 1 hour, I mean, 1 ampere current. How much time you have to give it for depositing W grams of Mg is what is asked in the question. Okay, I'll give you some time. Go for it. Hope everybody has taken down the question. See, I'm telling you, do not calculate. See how I did. Like this, you keep on doing. At the last, you can do the calculation. Okay, whatever the number, multiplications, divisions you're gonna get, just keep it. Especially
Sir,
for this
it
problem.
was bad, sir. Sir, after by passage of 1 ampere for 1 hour, what's after that? What's the question?
By passage of 1 ampere current for 1 hour. The question is,
Ah.
find the time required to deposit. Find the time required to deposit W grams of Mg. W grams of Mg by 1 ampere current.
Okay, sir.
Right? So do not calculate anything. Just go for the last. You are going to get the answer.
Sir, molar mass of Mg is
24.
okay, sir.
Sir, is it 3 hours?
I think it's correct. I'm not sure. Let me check. Okay. So first reaction is Ag plus an electron gives Ag. Right. So they are given 1 ampere current for 1 hour. So the charge would be 1 into, okay, basically charge 1 into 3600. Right. So my number of moles of electron used would be 3600 by 96,500. And you can see the number of moles of Ag and number of moles of electrons is same. Stoichiometry is 1:1. So number of moles of Ag would be this, or I'll directly write the mass of Ag. Mass of Ag, that is W. The W value which I'm finding easily, right? W grams of Ag is getting deposited. So I'll be able to find that out. So the number of moles is this much, same as the number of moles of electron into 108 would be the W value. This is the W value. Okay, right. Now let me go for the second reaction. Mg 2 plus 2 electrons gives Mg. No issues. Okay. Now they are given that the mass of Mg deposited is same as the mass of Ag deposited. So I know what is the mass of Mg, right? What is the mass of Mg is this much, right? So mass of Mg is 3600 divided by 96,500 into 108. Okay, now from this let me calculate the number of moles of Mg, right? Number of moles of Mg will be the given mass divided by the molecular mass, or the molar mass, that is 24. So that would be 3600. Let me change the marker. So 3600 into 108 divided by 96,500 divided by the molecular mass, which is 24. Okay, now that is the number of moles of Mg, correct? Now you see this is 2, right? Number of moles of Mg and number of moles, so basically 2 moles of electron gives 1 mole of Mg, right? So if I have this many moles of Mg, for this the number of moles of electron will be twice of that, isn't it? Am I doing it correctly? Yeah, this much require 2 moles of this, right? So number of moles of electron, yeah, number of moles of electron will be 2 into the number of moles of Mg. Is it not? Whatever the value, you can write it here. So 2 into 3600 into 108 divided by 96,500 into 24. No issues, right? Now what I have to find is, so I have already given that this is 1 ampere current for some hours. I don't know, whatever the time is. That's what I need to find it, right? So I'll just do everything ulta. This is the number of moles of electron. Number of moles of electron is charge divided by Faraday, right? So charge is what I have to, if I can find the charge is basically going to be Q I into T. So I can write this as 1 into T, 1 ampere current for this much. And I want the answer in terms of hours. So let me put 3600 also, because I'm going to get the answer in terms of hours. So 1 into 3 into 3600 divided by 96,500. This T, if I can find, and the number of moles of electron is this. Okay, so number of moles of electron, and this let me equate. So 2 into 3600 into 108 divided by 96,500 into 24 is equal to T into 3600 divided by 96,500. 96,500 gets cancelled, 3,000 gets cancelled. So what you have is basically T is equal to 2 into 108 divided by 24. So 2 and this I can do go for 12 times, right? And 12 and 108, how many times? 9 times. So T is 9 hours, not 3 hours. I told you, if you can just keep the calculations as such, do not calculate, everything will cancel to the last. Okay, so let me explain you one more time what exactly I did. So first is Ag plus, where is this? Where is the reaction? Ag plus giving, oh, I rubbed this part.
No, sir, it's in the top.
Oh, it's okay, fine. So Ag plus giving electron is plus electron giving Ag is this much. Now they have given 1 ampere current for 1 hour. So I calculated what is the number of moles of electron. That is 36,600 by 96,500. Now I know what is, I have to find what is the mass of Ag. That is what is given as W in the question, and that is this much into this number of moles into 108, right? Then I'm going for the second reaction where Mg is getting deposited. So this is the reaction. Now they have given 1 ampere current for T hours, which I don't know, but I know what is the mass of Mg deposit just because mass of Mg and mass of Ag are same. So W and W, that value I know is this much. Now I want to do whatever I did last time, exactly reverse the process I'm doing. Now I know the number of moles, mass of Mg. Let me calculate the number of moles of Mg, that will be this divided by 24. Right, and from this let me calculate the number of moles of electrons. So 1 mole of Mg requires 2 moles of electrons, so this many moles will require twice the amount, right? So done. So that is calculated number of moles of electron. Again, from number of moles of electron I use the formula Q by F, right? So Q is I into T, that is 1 into T into 3600 because I want in terms of hours, divided 96,500. Now you get number of moles of electron, this value and this value, you equate, you are going to get the value of T as 9 hours. Is it okay?
Yes, sir.
Right. Good. Right. What is the time? Okay, maybe. One last question. We'll wind up. And with this, electrochemistry is wound up. Right? Okay. So I have to rub this. See, if you would have calculated each and every step, you would have completed this problem only after 1 hour. Let me tell you again, given that you're not using calculators. Okay. Okay. So what they are telling is I have 1 mole each of AgNO3, CuSO4, AlCl3, and SiCl. Okay, right? And to each of this, right, I give 1 Faraday of current. Is it? Yeah, 1 Faraday of current is passed through all of these. Okay. Now what they're asking is number of moles of Ag is to number of moles of Cu is to number of moles of Al is to number of moles of Si. This is what you need to find. Okay. Right. So I have 1 mole each of this, and to each of this I give 1 Faraday of electricity. Right. I'm asking you, what is the number of moles of each of this getting deposited? Now, right, you go for your Faraday's second law here. Okay. So if at all you want to type down the statement, please type in the statement. Faraday's second law of electrolysis. Right, it states that for the same quantity of electricity, passed through different electrolytes, for the same quantity of electricity passed through different electrolytes, the mass of substance deposited in each electrolyte, is directly proportional to its equivalent masses. Right. So if I repeat the statement, for the same quantity of electricity passed through different electrolytes, the mass of substance getting deposited at each electrolyte is directly proportional to its equivalent masses. Okay. So if I have to talk it mathematically, that would be M1 is directly proportional to E1, M2 is directly proportional to E2, so M1 by M2 will become E1 by E2. Right, that's what it says. E1 and E2 are the equivalent mass, not electricity. Okay. Now you can either use this or you can actually use Faraday's first law only. See, it's pretty easy if you just do the stoichiometry or if you use this, either of this. Now, understand that Ag plus becoming Ag, correct? So the basically Ag plus becoming Ag is this. So I basically have 1 mole of this, right? Now they have given 1 F current, right? So you can say 1.
Sir, can I guess?
Yeah, tell me.
Sir, is it 1:2, 2:3, 4?
That's a good guess, but mathematically wrong. We'll see how is it. Okay. Right. So you see here, I'll get one, say basically 1F means 1 mole of electron, isn't it? F divided by F will become 1 mole of electron. So this will be 1 mole. No issues. Okay. Now I have copper 2 plus, which requires 2 electrons to form copper. So now you see there is 1 F current, 1 mole of electron. 1 mole of electron, can I say, will give me 1/2 moles of copper? Because 2 moles of electron gives 1 mole of copper. Now I'm using only 1 mole of electron, 1 mole of charge, whatever it is, number of moles of electron is 1. Because
so
1
you
F
should convert all of that, sir.
doesn't matter. See, 1F means how much? Number of moles of electron is Q divided by F. Q is what is given as 1F.
Okay.
You understand?
Yes. So
1F divided by F will become again 1. So basically 1 mole of electron is passed through all of this is what is given in the question.
Okay. I get it, sir.
Right. So now number of moles of copper formed will be 1/2 moles, right? And can I say aluminium would be 1/3 moles, because Al3 plus 3 electrons will give me Al. So if I have 1, I'll get 1/3 moles of Al. Same way for Si4 plus or Si, I would have gotten 1/4 moles of silicon. Yes. So now what would have been the case here? Number of moles of Ag is 1. This is 1/2. This is 1/3, which is 1. This is 1/4. Right. So if I take the proper ratio, it's better to multiply by 12. Is it not? Because 4, 3, 4, 2, 3, 4, everything goes with 12. Right. So I can write it as 12 is to 6 is to 4 is to 3. This would have been the answer. This is where you mathematically went wrong. It's not 1 is to 2 is to 3 is to 4. It's 1 is to 1/2 is to 1/3 is to 1/4 is to 1/4.
Okay, sir. Yes, sir.
Right. So guys, I hope everybody understood how is it 1, 1/2, 1/3, and 1/4. It's all now you can even do it in terms of equivalent masses. You know how to calculate. Equivalent mass is equal to molecular mass divided by n factor. In this case, the n factor would have been the charges. For Ag, it's same. For Cu, it would have been molecular mass divided by 2. For Al, would be divided by 3. For silicon, it would have been divided by 4. Same thing you would have got it. Same ratio you'll get. Okay. Right.
Okay, sir.
So, right, this kind of questions can be coming from second law. Right. Okay. So I think we'll wind up here. Tomorrow we'll meet. Tomorrow I'll be starting with solutions. We'll do a couple of problems and then we'll go for solid state after that. Okay. Fine. Thank you, guys. We'll meet again.
Thank you, sir.
Thank you, sir.